Yeah, thank you very much for kicking the session off. And also from my side, ladies and gentlemen, good morning. Welcome to my webinar, how to enable industrial analytics, as Ayrton already said, with IoT platforms. And I'd like to take you on a journey from sensors to insights, and then in the end also actions, because what you might want to have when you are connecting devices, when you're connecting machines, you would like to get actionable insights out of the data that you're collecting. So welcome and thank you for joining. I hope I have some interesting bits and pieces for you that you can take from this webinar. First of all, starting with my first slide, what do you have in mind if you think of industrial IoT? What kind of machines is it? Is it rather something like this, which is a brand new latest generation friction welding machine from KUKA, which has built-in sensors, a lot of sensors, built-in connectivity, latest also architectural integration protocols with, for instance, OPC UA that you can easily integrate into cloud platforms, local systems, and all of that, and which even comes with an integrated portal platform, which helps you to leverage predictive maintenance and helps you to reduce the maintenance time, since it advises you on the right service point in time. So that's the one thing, I think, the one extrema that you could be working with. The other extrema is also a friction welding machine, is this kind of machine. Even the picture has bad quality since it's really pixel image, but it's also showing a friction welding machine, and I think it's not atypical since the IoT devices, they're investment goods which stay in production for decades. And therefore, if you would like to realize industrial IoT use cases, you have also to have those kind of machines in mind, which do not feature a lot of sensors, which may not provide any data at all. So retrofitting, if you'd like to connect a cell or a line, is a big issue as well. And well, I'd like to talk about how to derive those insights based on the raw data that might be available from a machine, from a device, from a sensor, and how in the end actually to get actions out of the data that you're collecting. And what my important statement is here, IoT platforms help you with that. And I'd like to dig deeper into the question, what is then the added value of an IoT platform in order to realize business models that heavily rely on machine data? Well, for business models, for more insights into machines, you need industrial analytics, and that's what IoT platforms can provide you. First of all, what qualifies me for this whole session? Who am I? Who are we at Device Insight? So Device Insight is pretty much a pioneer in the whole Internet of Things industry. The company has been founded in 2003 already, so we have more than 16 years of IoT experience, coming from times where it just was called machine-to-machine communications. And we are roughly 100 people at the moment that deal with realizing customer customized IoT solutions projects. Our work is based around the IoT platform called CenterSide, which is a horizontal IoT platform, and we usually do projects in the field of connected products, such as heaters, such as forklifts, such as, well, big coffee machines, vending machines, and that stuff. But we are also dealing with telematics. We're connecting the big car fleets. We're connecting agricultural machines and so on, construction machines. And last but not least, industrial automation is an important field of ours where we connect different kinds of machinery and also provide shop floor connectivity. I marked that orange because there's an important connection that deserves the color orange, since Device Insight has been acquired by KUKA, the robot builder. And as you've seen already with the example, we are doing a lot of KUKA related stuff, doing projects for KUKA, working together with KUKA, providing IoT products. So just to finish this marketing slide up, what's the range of our services? It starts with consulting on business model, on analytics. We provide requirements engineering. We don't do hardware on our own, so we're not a hardware builder, but we can advise on choosing the right gateway, the right industry PC, and so on. And for sure, connectivity is also an issue in many projects. And since we're providing and running the whole platform center side as software as a service, we also provide operations support and the project management. Good, but well, before digging into what the IoT platform offers, I would like to point out a few motivational examples of good examples of business cases where IoT data is actually helpful. And I'd like to start off with the grandparent of, well, subscription-based business models, because it's now already over 55 years old. I think it has been founded in 1962, where Rolls-Royce had the brilliant idea of not selling their jet engines anymore. I mean, they still do that, but they also provide an additional business model of, well, giving out full service to the jet engines, including maintenance, including operations of the whole thing, but they do not sell the jet turbine in this case, but they charge for the operation hours. And you cannot charge on any operational hour if you don't know it. So therefore, data is important. You cannot offer this business model if you do not have the data that you're actually charging on. So this is a business model, pretty interesting, and well, in the end, you have an action because the bill is based on the data that you're acquiring. But coming a bit more into nowadays, this is an example of one of our clients, the company called FEINTOOL. FEINTOOL is building fine blanking machines, so big, expensive tool machinery, which, well, for example, helps to build belt buckles and such stuff out of a metal band. And since this machinery has lots of customizations, properties, settings that can be optimized during production, FEINTOOL offers consulting services in addition to selling their machines. So they have a data scientist and domain knowledge expert ready for the clients, which is able or who is able to connect onto the machines based on the IoT platform in order to tune settings, to optimize settings, to get better process quality in the end. So this is an example where machine insight is offered and an additional service is then built upon the data. This is a generic example, also actionable example where Heidelberg Druck, as a printing machine manufacturer, together with the client, set up a pay-per-use model. So the customer does not buy the machine, but pays for the printed sheets. And yeah, that's a typical example of these paper XYZ, paper pick, paper use, paper printed sheet, where there's now coming more and more of these examples. I do have another one as well, where KUKA compressors in industrial IoT context rather well, sells the good that they're actually producing, which is compressed air, and not the tool, the machine itself. So air as a service is pretty, I think in industry, pretty known term. With a project also with lighthouse character, which is typical for these paper per X business models, which of course rely on the machine data. But I'd like to conclude with a project that actually we are doing. We are providing for KUKA. KUKA provides this as a product to their customers, and this is again now an insights-based product or project where in production lines you are able to apply or you are able to get more insights on the PLC data that is collected anyways. So let me get a bit more concrete here. KUKA is also using the software which you're seeing on a screenshot on the right side of the slide in their production when they are building robots. And what you are able to see is how many parts are actually built, how many production steps are taken, how many parts per hour were built, and what's the current OEE. But what's I think special on it is that they already use the tool during startup phase, for example, as a system integrator of automation in the field of automation. If you start up a new cell, if you start up a new line, you want to check if the throughput of this line actually reaches the specified values. So if you reach the targets that you outlined, and this tool enables you to check if every step works accordingly to the specification. So if you actually are producing in time and you are able to guarantee the output that you've been specifying. But it's not only a tool for the startup phase, it's a tool which is used during production as well, because you can track if any deviation is happening. So you get actually transparency. Let's say any production step deviates, since it's not properly calibrated anymore, you would be notified upon that, and with this increased transparency, you get increased availability of the whole process, since you actually know in which exact production cycle, in which exact production step you might have issues, and then you can directly recalibrate that step or have a look at that step what's going on. And if you have increased availability, for sure the output is then also increased. So I hope that these few examples were a good starter for the question of again, what is then the added value of an IoT platform in all these examples. And to answer this, I again like to go back a bit to the theory, where you, as a starting point, always would like to connect certain machine, device, sensor, not just for the sake of connecting the machine, but for a certain reason, because you might want to get insights on the machine usage, for example. And I think a pretty nice example is always the first use case on optimizing product. For me, as a product manager, what's really important is how are my customers, my clients, actually using, in this case, our product, our IoT platform. Where are they clicking? Which functionality are they using? What would be great to have some metrics to see if a certain feature is liked or disliked. And for machine builder, I mean, for IoT portals, that's easier because they are connected anyways, right? You could collect such data. But for a machine builder of a product, you're selling it, you're handing it over, and then you lose track, you lose the connection. But with the help of connecting these kind of devices, you still get the usage data. So you know how many hours is a device in service, how long are they actually operating it? Is it changing its position? Is the customer selling it? This enables, again, also cross and upsell potentials if you actually know how a machine is being used, right? And these other use cases, monitoring the availability of a machine, are rather user-centered, so that the user itself would like to know, is my machine working or not? Yeah, and then you get insights on that for sure. Another typical use case, which is in the field of actions, is the often mentioned predictive maintenance of smart services use case, where nowadays service is pretty reactive, right? The machine breaks down and the service personnel is notified, which is, well, not enabling you to reduce downtime and such cases. But if you'd like to do that or provide supply materials when needed, just-in-time delivery and spare parts, you might also need a connection to the machine. And the third example, which, well, is important in that journey from sensors to insights to actions again, are the also previously mentioned subscription-based business model, pay-per-use. You might want to even apply revenue sharing, or you could ensure your whole production process, since the insurance company knows based on that data what's going on and has knowledge and well, therefore is able to provide an insurance on the whole process. And my quote here is, an IoT platform helps you because it enables to scale out these use cases. I mean, in industry context, there's often PLCs used, right? PLCs do provide interfaces that you could connect to those PLCs, but the thing is, the data would stay local, would stay in the network, would stay close to a certain production cell or plant. And with the help of gateways and IoT platforms, you can scale these use cases out and apply them not to only single machines, single cells, but to the whole fleet of it. So that's one reason to provide IoT platforms. And basically, they also leverage access on the data, because you could potentially get access on data from everywhere. For sure, filtered. Not everyone is allowed to get access. That's clear, but you at least provide the possibility. And now, if we zoom deeper into what's needed to connect sensors, what's needed to get insights, so what features should an IoT platform offer in favor to provide you industrial analytics, we could look at such a graph. On the right side, the customer values rises, right? From raw data alone, you don't get too much value. From insights, you get a little, but if you actually have actions based on that insights, that might help your customers or might help yourself the most. But if the value increases, the sad message is always the complexity always also increases. But that's just how it works, I'd say. So first thing that you really need to do is get the sensors onboarded, make the data available. And that's rather, you could say, the least complex thing, that should just work like a charm. But here it's often all about protocols, different protocols, proprietary protocols, well, PLC protocols. And what we see here is that OPC UA is the new standard, is the new approach to make it really easy getting PLCs, getting machines connected and provide the data. And I'd like to show you also an example later on how easy it is to actually connect OPC UA based data to an IoT platform. If you have that machine connected, then it's about transparency. You can play around with this typical IoT use case, put my data points, put the values on a dashboard, and let your users investigate raw data values on that dashboard. So basically, it's about the visual inspection. You could come and have a look on what's going on, also remotely. But that's not too much of a value digging into the raw data itself. It's more about automation and getting insights automatically based on the raw data value that you're connecting. And then an IoT platform should offer you the possibility to derive KPIs, so key performance indicators from that raw data, or derive rules. A domain expert, a process expert might want to apply his knowledge to the raw data which is collected, and then let automatically be informed on that. But if domain knowledge and KPIs such as OEE numbers, overall equipment effectiveness, is not enough, then we come more to the field of machine learning, analytics, data science, where we try to first figure out with statistical methods on what's going on with data, what can we derive from that. And the statistics, I think, is a data scientist's best friend. You don't have to throw the latest neural network yet on the data. You can also easily correlate signals, cluster signals, and all that, put decision trees on data before actually applying machine learning or even, well, neural networks as a part of machine learning on that data. So that would be then again the next step that we are also giving an example on. So if you have this, you'll see I'll outline an insights actions pyramid afterwards. If we stepped up the complexity steps, we are coming to the actions part. Well, absolutely low level, easy to understand. If you figure something out on a dashboard, you might want to apply some manual action. If the temperature of your autoclave is too high, if the pressure is too high, you might run and pull the plug to stop an upcoming catastrophe. Just kidding. But since it's low level, you might want to automate this. You might want to log events that were derived from machine learning statistical methods, from the condition monitoring rules, and you might to trigger an alarm. You might want to inform someone. That's also which an IoT platform offers easily, inform you about the findings that were actually derived in the portal, in the platform. But the nicest thing of it, if you do that automatically, so if any finding happens, then you let an automatical action happen in order to maybe start a service task, to inform a service technician, create a service technician order, send out some supply materials, send out some spare parts, or reconfigure a machine even based on some predefined configuration settings. So, and well, looking at all these nice examples here from KPIs, from transparency and the rapid asset onboarding, I'd like again now to go over to a real example on how we connected an industrial cell which produces robots. So we have 3 layers here. 2 of them are located on site in the plant, in the manufacturing plant. We have the machine layer for sure, where all the machines, the robots, the tool machineries, and so on are residing. And we also have an edge layer where we provide connectivity towards the IoT platform, towards the cloud. So in this example, we had 2 tool machineries from Hella. We had the gripper. We had a robot that took pieces from a turntable to the tool machinery and back. And they for sure all provide certain amount of data on proprietary protocols. And also in this context, on edge layer, we have a cell PLC, Siemens A7 cell PLC, pretty typical example, I'd say, on how a production plant is connected in a shop floor. And if you have OPC UA on that, if the PLC is of a current generation, then it offers OPC UA connectivity by itself. But if you don't have that, you might want to add a gateway, a gateway on connected to the S7 in order to translate the protocols. And here we have an OPC UA server, which then is communicating via OPC UA with a small edge device, with a small industrial PC or gateway. And well, it also communicates directly with the robot controller, because the robot controller itself also provides OPC UA, but for sure it could also be handled through the S7. But the more sources feature OPC UA, the easier it actually gets in order to onboard devices of a cell. And then from this edge device, data is fed into the IoT platform itself, where it is then provided in a way you actually are able to perform all the previously mentioned things like condition monitoring, KPIs, and so on. For sure, the edge device itself also enables filtering data. You don't have to transmit anything. For example, if you don't want to, as a manufacturing responsible, you could apply some filters already here in order not to transmit all data. But that's how we typically see such a setup: a small edge device which is close to shop floor, which is able to access the local OPC UA service, which don't have to be well, given access to the internet and so on. And this edge software itself uses VPN or TLS encrypted communication channels, uses client certificates in order to authenticate against the platform, so data cannot be accessed, data is kept secure, and devices for sure are properly authenticated. And now if we are looking at this scenario, I would like to give you then again some examples of what we've been doing with the data, and I'm comparing the previously mentioned fields of action, so the transparency dashboards, KPIs, rules, with an automation pyramid. So many of you know the industrial analytics pyramid, and I outline an analogy here. The easiest thing and the basic task is this asset onboarding. Then you get the transparency based on the raw values that you're collecting, and then you can derive KPIs and rules on that and apply statistical methods up to machine learning algorithms, and then on the other hand also configure some actions. And I think this is the evolution of an IoT platform. The commodity thing is onboarding, right? You have to provide an easy onboarding. You have to provide transparency and well, the space for distinguishing between different IoT platforms to line up some USPs is in the upper fields, where it starts with the KPIs and the condition monitoring rules, and up to the actions. And I'd like to take this analytics pyramid to tackle through, at least from here, from the onboarding up until the machine learning, to give you some concrete examples of what we are offering and how we provide onboarding, how we provide the transparency, how we provide KPIs and rules and all that. And I'd like to start off with a pretty provocative statement. It's as easy as taking 1 minute of your time to connect an OPC UA data source on shop floor level with an IoT dashboard in the cloud. And I provide a little video for you to show that, what the setup is like at the moment. You have an OPC UA server, and in our example, we have a cooling chamber. This cooling chamber offers temperature values through an OPC UA server. On shop floor level or close to the cooling chamber in the same network, we have such an center-side edge gateway which resides there, which is able to access the OPC UA server. And this edge gateway provides a secured channel to the IoT platform and in the end to the dashboard. So, and what I'm now showing in the video, I hope it's easy to follow that video, is how the connection through this edge gateway to the OPC UA server is performed, how data is subscribed, and then in the end printed out on the dashboard, well, a temperature value. And I just jumped into the video, jumped into our IoT platform. At the moment, we are on an empty dashboard. And the first thing that I want to do is to configure this UA connection. So I'll start off with choosing OPC UA connector name. For sure, I do have to enter the IP address of this OPC UA server. I give that configuration a name, cooling chamber, and I click on save. What now happens is that the edge device is told about this new upcoming configuration, and it discovers the OPC UA tree, which is pretty comfortable because you don't have to know the infrastructure of this OPC UA server, the data model. You can just, like in a file browser, browse through the nodes to the data points that are available. And I picked 4 data points, 4 temperature data points, and subscribed this edge device on those 4 data points. And the configuration has been synced. I'm going back to my dashboard, click on edit, and add a widget which displays me the latest data point value. Here I have those 4 temperature values available, and I want to output them as a gauge chart. Yeah, you actually already see the result. I added a gauge chart widget which displays me the temperature value that has been recently just fetched from the OPC UA server. The whole video takes about 1 minute and 12, so it's really pretty easy to configure OPC UA data sources to an IoT platform in a, for sure, encrypted and secured way. The next step on our, so that was for the sake of showing the rapid asset onboarding and the transparency on the dashboard. You could for sure also dig into the raw data values. But the next thing that I'd like to show you is the KPIs and rules. And if you think of PLCs, you pretty often get status flags. Is the machine currently idling? Is the machine currently running? Is the machine provisioned? And as a maybe shop floor manager, what's interesting for you in order to get your OEE figures is to get out of the real data the uptime of the machine. And as you see on the screenshot, we have a nice tool. We call it data processing, which provides you the ability to calculate KPI data. For instance, this is a term in order to get the uptime based on a Boolean or based on a status variable called machine online. So if the machine is online equals 1, then please count the duration when this data point had the value of 1 and divide it by the interval that I'm looking at. An interval could be the shift, for instance. And then I get a percentage value, the time of this interval where the machine actually was in the state of online. And again, I could then display that value on the dashboard high. So, and informing yourself about low and high values. By the way, I'm always comparing that. It's not really complicated entering such terms. I always have this Excel analogy in mind. So if someone is capable of entering Excel formulas, which I think most of the people listening definitely are, then those people you're also capable of entering KPI definitions here. So the next thing is the rules. Let's say if something is too high or too low, I want to have an event created and logged. And that's also necessary in order to get insights on the machine, right? To apply some condition monitoring rules. And for sure that should be easy to achieve. You might want to get notified if things don't work properly. And for sure that the shop floor managers or process experts do have their domain knowledge, but they don't probably have the programming skills. So we wanted to make it real easy and provide a graphical algorithm builder, so-called. But I think it's also easier to show a little video here how that actually you can create a rule, and in the end, when you create a rule, you get an event, and the event can be well shown in comparison to the data, and I'm showing that to you as well. In this case, we have a bottle filling machine, and this bottle filling machine fills up bottles, and the bottles, the quantity, the filling quantity shall not be too low. So we are producing a rule which monitors if one of the 3 bottles which are filled up at the same time, if the quantity is too low, then we are going to trigger a filling error event. Since it's 3 bottles which are filled up at the same time, I connect 3 data points to that rule and select the data points, filling quantity for bottle 1, filling quantity for bottle 2 and 3. And then I will configure the rule that I want an alarm if any of the 3 values is less than 491 milliliters in this case. I can save that rule, and then it immediately gets active on that asset. And I can look on the events, I can look into the raw data, so that's the filling quantity for bottle 1, for each and every bottle. And then I'm comparing it to the well, event that actually has happened. And if you see now in these 3 cases that I outlined here, the filling quantity is below the 491. So you easily get an information when data actually, or when there was a coincidence, a situation that you need to look at, and you don't only get that logged into this event log here, but you could also be informed, for example, via email. So that was an example how condition monitoring would work in order to get a bit higher on this industrial automation pyramid. So coming to the statistical methods and machine learning part of it, here I have an example for you with statistical methods where we, for instance, based on collected data, looked at error cases. So if it was a construction machine or different kinds of construction machines, three different kinds of construction machines actually, how severe were the errors, how many cases that led actually to the machine downtime, where only a certain subsystem was affected, where slight disturbances, or where the error reasons were still unknown, just a few of them. And we had a big signals, many error events that then were just in a small project visualized in order to get more knowledge on the cases. And I think this is where the statistics comes in, where the data scientist picks his favorite tools, Python or R, and gets access on the data which is saved in the IoT platform and does its visualization. And another example would be the origin of the errors, what subsystem was affected. And as you can see here, lots of the cases were due to electronic issues, and a few because of hydraulic errors, and the engine was not so much the error case. So that's what you would typically find out by just applying some statistics. And if you go to machine learning, and in the industrial field, we often have forecasting issues to detect. So when is a service due, or when is a the situation to predict some situation in the future. So you apply a forecasting algorithm, and the other pretty common use case is anomaly detection. If something works out of order, is not consistent with just the normal behavior, you might want to be informed as well. So these are two typical fields in industrial IoT from our perspective, to forecast or to well, find anomalies in the data. And here we have also an example to forecast machine engine hours, so the usage of a machine in order to set the service at the right time. Let's say that this kind of machine here needs a service every 400 operation hours, and you might want to make sure that this service does not happen, or the service is not needed in a situation where you are relying on that machine heavily. And then if you forecast based on the seasonality of the machine, you can shift then the service appointment a bit earlier or a bit later based on the forecast. And what you see here in the visualization, for sure the operation hours, the longer that you forecast, the uncertainty interval as well. But you can, at least in certain borders, predict based on the seasonality, based on the usage of the machine, when those 400 hours are again met. And this is just a visualization, but it could easily be built into the IoT platform, built into the dashboards, in order to tell someone, well, please take care, because in the next, let's say, a week, service of the machine is actually due. And that this kind of use case was also implemented with the friction welding machine that I've shown at the really first slide of the presentation. Since we are here in the field of data science already a bit, I would like to say a few words how such a project should be concluded, should be done. And I think there is a lot of misconceptions actually happening, because the term predictive maintenance is really used frequently, and often here, like, you have to have data, you have to have tons of data before you can do anything. And for sure, data is important, but it's not about just tons of data if you don't define a clear goal. So the misconception often is that you were told, as the person responsible for introducing, for example, a new business model, new smart services, that you have just to collect all the data that you can get. And then you apply a machine learning algorithm, just like a glass bubble, and fed that learning algorithm with all the data without giving any context. And then the correlations that you find, they have really no significance. You might be disappointed in the end, because you don't get out of your expensive, nice data science project, you don't get any reasonable result. And therefore, that's not the way it should be. That we would really have significance where it's worth spending some research and doing a data science or analytics project. And such projects could often be where, in warranty cases, you lose a lot of money, which happen frequently, and where the financial impact is high. So you try to filter out those use cases, or where let's say that the process quality is highly affected, and if you could do something for the process quality for your customers using a certain machine, then this might be an interesting use case to look at. And by identifying such use cases with service, with product management, with the innovation managers of your company, you get the domain experts that actually know the background of the processes going on in that use case. which you then bring together with someone who knows about statistics, who knows about data science, who knows about the machine learning algorithms, in order to define the right data set, to define the right also intervals that the data needs to be recorded. And if you have that prepared, you're able to define a machine learning model which suits best. And then you get a solution which is really specific to your problem that you're having, and that then you from the beginning you've been thinking about the business case behind, and then the whole approach makes sense in the end. And there's even a standardized model on that. It's the CRISP DM process that we are also following, so cross-industry standard process for data mining. And here it's like a circle. First, you have to start with the business understanding, so you have to define a problem that you might want to get solved. And after that, it gets into data understanding, preparing, so selecting the right data, explore it, provide it for the model development. And here the actual machine learning takes place. You select an algorithm, you train that algorithm, and you validate the results. You reselect, you retrain with additional data, and then you get better and better models, which can be evaluated and then also deployed in real production scenarios. And that's the process typically shared between the ones with the domain knowledge and the ones with the analytics expertise. And concluding the circle with the IoT platform that I'm always talking about, when you deploy that model, the IoT platform is of importance model, send around notifications and whatsoever. And I'd like to come to an end here, because we now have been going through the whole pyramid of collecting data, getting additional value out of the data. And I'd like to conclude with a quote from Steve Jobs, because it fits here really well. Because it's pretty close to how we are working, and it's about starting small, think big. Don't worry about too many things at once. Take a handful of simple things to begin with, and then progress to more complex ones. Think about not just tomorrow, but the future. But future business cases, and put a ding in the universe. And well, if you liked what I was saying, I'd like to point out to two white papers that have the same direction. They are about 10 hints and tips for your IoT project, artificial intelligence in IoT practice. And if you are rather a hands-on person, you might also want to start from the side to really experience of what I was just talking about. Yeah, and that's just finishing up a typical holistic view where you can, well, you start implementing use cases one by one. I hope you could take something with you from my presentation.